two ships set sail. This is more cosine law, but they're making it a little more real-lifey by talking about ships. They start out at point P. One of them goes 7 kilometers and ends up over here at R. The other one starts at P, goes this way, and ends up at Q. And they say at that point the ships are 13 kilometers apart. Determine the angle between the directions of the two ships, meaning this angle here. As before, two ways that we can handle this. We can relabel this triangle so that it contains A, B, and C and fits the formula more nicely, or we can rewrite the formula so that it fits these letters. Rewriting the formula means you have to recognize the angle that you're trying to find in the middle is, this is your center line. This is where the formula would begin and end. It would start with p squared equals, and it's going to end over here with cosine capital P. Then the Q and R are the side, or the off-center values. And so with those, you'd get your Q squared plus R squared minus 2QR. That's how I fill it in anyway. If you want to do that way, brilliant. It will work, I promise. You'll get 13 squared. Well, actually, you may want to solve this for cosine P before you go on. So it'll end up being cosine P, I'm doing this kind of fast, Q squared plus R squared minus P squared over 2QR. You know what? I'm curious. Let's run it off, and then I'll do it the other way, and we'll confirm we get the same answer both ways. And if they don't come out the same, I will panic. Q squared is 7 squared plus R squared is the 8 minus P squared, which is the 13, divided by 2 and divided by 7 and divided by 8. I get the cosine P is minus 0.5. Now if you go second cosine, you should get that P is, I know this one, 120 degrees. I'll check it on the calculator to make sure. Yep, P should be 120. All right. Now the alternate version. We'll borrow this triangle. And we'll scooch it over here. There we go. Get rid of that noise. That's from something else which we don't need. All right. Here's the other version where we modify the triangle instead. Our formula, you recall, goes a squared equals b squared plus c squared minus 2bc cosine a. So we're going to say goodbye to these letters, which do not fit the formula, and hello to the following letters. Big A is the angle we want to find. Little a is the side across from it, so this is our center line again. The formula starts with little a and ends with big A. And then these sides are going to be B and C. Now if you solve this for the angle you want, you get b squared plus c squared minus a squared. I'm doing this a little bit faster because you've seen it before. And when we calculate this, we get 7 squared plus c is 8 squared minus a is 13 squared divided by 2 times 7 times 8. That looks pretty familiar to me, but I'll crunch it one more time just to make sure. 7 squared plus 8 squared minus 13 squared equals divided by 2 divided by 7 divided by 8. Again, we get cosine A is negative 0.5, so of course when I hit second cosine it's going to spit out the same angle, 120 degrees, which means right up here between the courses of the two ships is 120.